In section 5.1, we're going to look at quadratic functions, and the first thing is to notice what a quadratic function equation looks like, which is, it could look a couple of different ways. One is standard form, which is f of x is equal to a times the quantity x minus h squared plus k, and this form is very helpful in finding the vertex, because the vertex of the quadratic, which is just the maximum or minimum point, is going to be h comma k. And then general form is f of x equals ax squared plus bx plus c. Okay, and so this is another helpful form of a quadratic where c is actually the y-intercept, and so pretty easy to tell what the value of the y-intercept is. Another thing that you could tell just from looking at the equations is how the quadratic opens, if it opens up or down, based on the sign of a. So if a is positive, the quadratic opens upward, but if a is negative, the quadratic opens downward. Okay. And one other thing that you probably need is the vertex formula. And so if the equation is in general form and you want to find the vertex kind of quickly, it's h is equal to negative b over 2a, and then y, the y value, or k, is equal to the function value when x is negative b over 2a, or in other words, f of negative b over 2a. So we're going to go over graphing quadratics. I'm going to find the vertex of each of these given functions and then see if we can find another point on the graph to be able to make a sketch. Okay, so for a, f of x equals x squared minus 4x plus 3, the first thing that we can do is find the vertex by using the formula h equals negative b over 2a. And notice that b is negative 4 and a is 1. So altogether we get 4 over 2, which is just 2. But we also need to determine k, the y value of the vertex, and so we're going to plug 2 into this function. And so really we're just finding f of 2, and that's 2 squared minus 4 times 2 plus 3, or 4 minus 8 plus 3, or negative 4 plus 3, or negative 1. And the vertex of this quadratic is at 2, negative 1. Another clear point that we can determine from this given equation is the y-intercept, which is at 3. And these quadratics, they have something called an axis of symmetry, which is just an imaginary line that passes through the vertex. Okay, so the axis of symmetry in this case is this line at x equals 2. And therefore, we can reflect this point, the y-intercept, over this line and find another point that's going to be on the graph of this function. And then make a curve that passes through these points. Okay, for part B, we also need the vertex, and so h is again negative b divided by 2a, and that's negative 6 divided by 2 times negative 3, or negative 6 over negative 6, which is just 1, and k is equal to the function evaluated at x equals 1, or g of 1. And that's negative 3 times 1 squared plus 6 times 1 minus 1, or negative 3 plus 6 minus 1, which is just 2. And therefore the vertex is at 1, 2. Notice this parabola also opens downward because a was negative, a was less than 0. Okay, but another important point that's easy to tell from this equation is the y-intercept, and that's at -1. Okay, using the axis of symmetry again, we can reflect the y-intercept over this line and get another point on the curve, which is at 2, -1. And then lastly, connect to form a curve.